Hi friends, welcome to GMK tutorial. In this video, we are going to see about the CE configuration by using a current mirror circuit. So this is a basic block diagram of a CE configuration. This is a basic block diagram of a CE configuration. In this, here emitter is connected to the common to the both input terminals as well as the output terminals. So that's why it is called the CE configuration, right? So after that, obviously, if you are treating in points of the transistor point of view, transistor is generally called as a current control device. I think all of you having a this kind of the basics. Okay. At the same time, in case of the current control device, obviously input is a current. At the same time, output is also in terms of a current point of view. Suppose if you want to achieve a high gain in case of the transistor point of view, obviously you need a maximum, you need to get a maximum gain. At that time, obviously the resistor is also plays a very important role. Okay, resistor plays a very important role. So due to some variations in case of the corresponding uh, temperature parameters and supply power supply variations, obviously this resistor is limited the gain of the transistor. So that is also one of the drawback. So suppose if you are taking AV is equal to minus GM into RE or minus GM into RC, or maybe or not like this. Okay, so this this is a limits the corresponding gain of the transistor. Okay, so that is also one of the problem actually. So for that purpose, we can replace the corresponding resistor with some active device, that is nothing but a transistor. We can get some kind of a better results compared to the first case, like a passive point of view. Here also same thing. The active element is also needs some kind of a biasing element, like RBT is also act as a biasing element. So is there any variations in the temperature variations, or maybe variations in the VB or maybe supply voltage variations? Obviously the current is also changes in the corresponding device. So that is also one kind of the limitation. So for that purpose, we need a circuit. The circuit produces a constant current. That is a very important thing. So for that purpose, we are shifted into the current mirror circuit point of view. So this is all basic information related to the current mirror. Okay. So just yesterday we covered all kind of all these topics, right? So just move on to the today important concept is nothing but okay. Now we discuss our discussion related to the current mirror circuits are used in case of the CE amplifier. So in the last couple of minutes before, we see the basic circuit diagram of a current common emitter amplifier. Okay. So here also same thing. Let us see very carefully here. It represents the same circuit like almost, right? So let us see here. So this part represents a basic circuit whatever we used in the last application point of view. Like this circuit represents a common emitter amplifier. Okay, this circuit represents a common emitter amplifier. Common emitter amplifier. Common emitter amplifier. At the same time, let us see here. So the problem is that in case of the common emitter of amplifier, only the corresponding element, that is nothing but the passive element is replaced with some active elements, like that is a criteria. So here the basic thing is that in case of the common emitter amplifier or maybe common corrected emitter point of view, wherever you are using a constant current source, that constant current source can be replaced with a current mirror circuit. That is the application of a common emitter circuits can be generated, or common emitter circuits can be designed with the help of a current mirror. That is very important, guys. Okay. So the basic only difference is nothing but transistor is nothing but in case of the transistor point of view, we are using three types of configuration, whether it may be CB configuration or maybe CC configuration or CE configuration. CE configuration means the emitter is common to the both input terminals as well as the output terminals. So in this point of view, here the collector, whatever the resistance, that resistance can be replaced with some circuit. This circuit is generally called as a current mirror circuit. That is the simple variation in case of a CE amplifier with a current mirror circuit. So let us see here this Q1 transistor. At the same time, this Q2 transistor, both are having a identical characteristics. That means this Q1 and Q2 transistor having a identical characteristics. At the same time, here C is used for coupling capacitor, where R1 is used to biasing element, Vin is the supply voltage. Vin is the supply voltage. At the same time, if you go for the Q2 point of view, Q2 is also having a identical properties or identical characteristics of the Q1. Therefore, the IB2, that means the current passing through the base of the Q2 transistor is equal to base of the transistor 1. That means IB2 value is equal to IB1. Suppose if you want to get a IB2 value is equal to IB1, obviously the resistance R1 and R2 is also similar. Okay, whenever the resistance R1 and R2 are having the same value, then only you can get the IB1 current is equal to IB2 current. Okay, so from this discussion, let us see here the current, whatever the current IC2, that is nothing but current passing through the Q2 transistor is also equal to current passing through the Q1 transistor. From this, we can say that the current IC1 is equal to IC2. Okay, IC1 is equal to IC2. At the same time, if you go for this point of view, just this point of the current mirror circuits point of view, here also some more analysis is there. So in this case, this is nothing but a Q3 transistor and Q4 transistor. Q3 and Q4 transistors are also identical transistors. So as per current mirror circuits point of view, whatever the current passing through this circuit, obviously it is nothing but actually it is a PNP transistor. Okay, actually this current mirror circuits can be generated with the help of a PNP transistor. So this Q3 and Q4 transistor maintains a identical characteristics. Therefore, the current passing through this terminal is equal to IC4 or is equal to IC4 is equal to IC2. That means whatever the current passing here, that is equal to this one. That means it exhibits a mirror current of the IC2. So that's why it is called a current mirror. Current mirror circuits means that the current in the one circuit is obviously exactly equal to the second current in the second device. So that's why it is called a current mirror. It is nothing but this current is a replication of this one, right? This IC2 current is equal to the replication of this, means or maybe I4 or maybe I1 current. This I1 current is a replication of I2 current. That's why it is also called as a current mirror circuit. Okay, I think up to now it is very clear, guys. So there is the only variation in case of the CE configuration. Just current mirror circuits are placed in the load element or maybe RC element. RC element is just replaced with a current mirror circuit. You can achieve the CE configuration with the help of a current mirror. That's it only, right? I think it is very clear, right? So this is also some of the assumptions, like the current mirror circuits can be generated with the help of this circuit. So this is nothing but a PNP transistor. Current mirror circuits can be designed with the help of a PNP transistor. Therefore, whatever this reference current is there, that reference current is equal to the reference current is nothing but the passing through the corresponding Q3 transistor. At the same time, IC4 is equal to the current passing through the Q4 transistor is equal to IC2, that is ISO4 by IS, that is nothing but reverse the saturation current of the Q4 transistor divided by reverse the saturation current of the Q2 transistor is multiplied with the IC 2, that is also called as I reference, that will give rise to the I4 transistor. Okay, that is all about the current mirror circuit in case of the CE configuration model. That is the only just basic thing, right? So let us see here some more analysis related to the, if you want to find out the voltage gain, this is a formula for this one. The voltage gain for this one is equal to V0 is equal to minus GM1 into R01 into R02. So R01 is nothing but output resistance, R04 is also nothing but output resistance across the Q4 transistor, R01 is the resistor across the R1. Basically, the formula is nothing but V0 is equal to minus Gm into R0. Okay, minus Gm into R0, where Gm is nothing but a transconductance. That is nothing but 1 by resistance of the RAC. At the same time, R0 is nothing but the corresponding parallel resistance. That means if you are taking the output across some element, right? So output taken at this element. So this is nothing but obviously output point of view. So it is also having some resistance. It is also having a two resistance. That means if you are taking the output resistance, obviously it is nothing but a these two resistors are connected in a parallel configuration. Therefore, R01 is parallel to the R04. So that is the equal to the same analysis. So coming to this one, the circuit represents a small signal equivalent of the corresponding CE configuration amplifier with the help of a current amplifier. Basically, in the circuit, let us see very briefly. Okay, so small signal analysis is nothing but why we are taking the small signal analysis means that if you want to find out the voltage gain, you don't require any kind of the DC voltages. Just we need a AC analysis only. Why? Because it is not required means the DC biasing is only used for Q point selection only. Once if the transistor is in the active condition, no need to consider about the DC analysis. You just think about the AC analysis, whether the transistor is increases the output voltage, how far, or maybe how much amplification can be performed by the transistor. That is the best, that is a very important thing. Suppose if you want to carry out the small signal analysis, obviously just you have to, this capacitor can be short circuited. Okay, so whatever the voltage sources, maybe VDD, like suppose DC voltages, and DC voltages can be short circuited and the current sources can be open circuited. That is also some of the analysis. So coming for this kind of view, this complete circuit is not having a, it does not carrying any kind of the signals. So that's why you don't want to think about the current mirror circuits point of view. Okay, just if you have any doubts, just you will go through the equivalent circuit diagram for the Q4 transistor. It is just only left out with only one resistance one. Okay, just you will go through that one if you have any doubts. So if the time being, just very briefly recap all those things, just a bit of time only. Okay, so let us see, this is a pi model for this one. So here also Vi is the input signal, where R pi represents the, that is nothing but input resistance. R pi represents the input resistance. So Gm into V1, so Gm into Vin, this is nothing but, this is nothing but represents a voltage control current source. This is Gm into Vin represents a voltage control current source. At the same time, just as of now, we discussed the point just before a few minutes, just a little before. So in case of the current mirror point of view, just we have only one resistance. That resistance is number R04. So okay, that is the only equivalent model for a current mirror. So that's why it is having only that resistance only. At the same time, if you go for the circuit point of view, just we have a R01 is nothing but an output resistance in this case only. Output resistance in this case only. So that is a basic difference between the normal circuit and small signal model of this one. So with the help of this circuit, we can find out the output resistance. Output resistance V0 is equal to, generally output resistance V0 is equal to, so output by input, right? So output is nothing but, in this case just output voltage is nothing but the voltage drop across, that means it is a resistance, it is nothing but some current. Therefore V is equal, V0 is equal to I into R, right? That is a general formula, right? So here the current direction in this direction, that's why you will get a negative sign. Therefore this current Gm into Gm Therefore, R01 into parallel with R04, you will find out the corresponding voltage in case of the circuit also. So this is all about the discussion related to the CE configuration can be designed with the help of a current mirror circuit. So here V naught by V in, therefore you will get like this. So AV is nothing but voltage gain. AV is equal V naught by Vn. So just V naught by Vn, that is equal minus Gm into, so this resistance value. This resistance is nothing but R01, R04. These two are connected in a parallel configuration. The equivalent resistance R01 into R04 divided by R01 plus R04. This is the circuit diagram point of view. Okay.